Good afternoon. Today we are going to look at algebraic expressions. An algebraic expression consists of at least one variable, one number, and one operation. That is to say, we can have an expression like n plus 9. In this case, the n represents a variable, and then the 9 represents what we call a constant. A variable is just a letter that is used in place of a number. Now, when you replace a letter by a number, we call that one a variable in mathematics. Generally, algebra is the mathematical representation of numbers by letters. When you represent numbers by letters, then we are dealing with what we call algebra. Then we have also what we call a constant. In algebra, we have what we call constants. A constant is a number that stands by itself. For example, in the situation we looked at above, the n plus 9, 9 represents a constant. You find that it stands on its own. Then we also have what we call coefficient. In algebra, we have what we call coefficient. The coefficient is a number which is in front, and it is attached to a variable. Any number that is written in front of a variable it's a coefficient. For example, if I write 5x plus 3, 5x plus 3 there, the 5 is what we call the coefficient. Then the x is the suffix. Then the 3 is what is referred to as a constant. So in the 5x plus 3, the 3 is the constant, 5 is the coefficient. Now, this x here is what we call the variable. Sometimes we can call it a suffix, and then the number written in front of it is called the coefficient. We have what we also call terms in algebra. Terms. Now, when you look at this expression, 5x plus 3, the 5x, the whole of this, which is 5x, is what we call a term. Then the 3 is also a term. Therefore, this expression, 5x plus 3, consists of two terms. That is to say, the 5x and then the 3. There are two terms. Each part of the expression forms what we call a term. If I have an expression like 9x plus 6, this one is a term, this is also a term. So this expression consists of two terms. If I have 3x squared plus 5x plus 6, this is an expression which consists of three terms. There is this one, this is the first term, the second term, and the third term. So each part of the expression forms what we call a term. We are going to look at how we can form algebraic expressions. How do we form algebraic expressions. Algebraic expressions can be formed from statements. In statements which we make in everyday life, we can form algebraic expressions out of them. One can state a statement. That statement can be put in mathematical form. And that mathematical form of writing such a statement is what we call algebra or algebraic expression. We can look at a situation like this, a statement like this, that 9 increased by a number. 9 increased by a number r. So that one is a statement which is in English. We can put it in mathematical form. So in mathematical form, 9 being increased by r is written as 9 plus r. It means we are increasing the 9 by r. So we have put it in short form. We also have another statement like 14 decreased by a number. 14 decreased by a number. To put this in short form, this one will be, we say 14, assuming the number is x. If the algebraic expression becomes 14 minus x, it means you have decreased 14 by x. We also have another situation like 6 less than a number t. 6 less than a number t. So the statement is 6 less than a number. So it means that t minus 6. T minus 6. So the statement will be t minus 6. T minus 6. We can also have another example where we have the product of 5 and a number n. In mathematics, the word product is a number obtained as a result of multiplying 2 or more numbers together. So if I say product of 5 and n, it means we have to multiply 5 by n, which is 5n. So the answer will be 5 times n, and its product is 5n, just like that. So we can also have another statement like 32 divided by a number x. 32 divided by a number x. This one will be written as 32 divided by a number x. So I've put it in short form. So the short form of writing statements mathematically is what we call algebra. So that is how we form algebraic expressions. We can look at what we call like and unlike terms. Like terms are those terms which have the same variables. The same variables. If the terms consist of variables which are the same, then we say that those are like terms. For example, we can have 3b plus 2b. 3b plus 2b. So you can see that this is an algebraic expression which consists of the same variables. The variables there are b. So since the variables are the same, we say that those are like terms. We can also have another situation like a plus 5a. A plus 5a. This is also an expression that consists of like terms. Then we have what we call unlike terms. Unlike terms, these ones are formed from an expression that consists of different variables. Variables which are not the same are what we call unlike terms. In everyday life, when we add variables which are not the same, then each is counted differently. Like if I say, if I have a number of goats and then a number of sheep in a certain farm, when I'm counting them, you will count the goats differently and then the sheep differently. We can have 5 goats plus 5 sheep, or 9 dogs plus maybe 3 chicken, something of the sort. Those are unlike what? Terms. So in this case, mathematically, we may have unlike terms. Unlike terms are represented by different letters. We can have maybe 5b plus 7a. These are unlike terms. You cannot simplify them further. Why? Because they are unlike. 5b is different from 7a. We can have maybe 3b plus 2c. These are unlike what? Terms. 4b plus 2x. These are all what? Unlike terms. So generally, unlike terms are those contained in an expression which consists of different variables. Example. We have 3a plus 12b, 3a plus 12b, then plus 4a minus 2 minus 2b. So you can see that this is an expression which consists of unlike terms. So what we do, we collect those terms which are the same together. We shall have 3a, then we bring the 4a plus 4a, then plus 12b, then minus 2b. Bring them like that. Then from here you can now continue with the addition, whereby we shall have 3a plus 4a, we have 7 what? A, plus 2b, 12b minus 2b, we get 10b. So here we cannot continue further because our expression now consists of unlike terms only. We can have another example also, another one where we have 2x minus 5b example 2, we have 2x minus 5y plus 3x minus 7y, then plus 3w, plus 3w. So this is an expression also that consists of unlike terms. Collect the like terms together. Here, the terms which contain x, bring them together. Those which contain y, bring them together. and those of W. So in this case, we shall have 2x, bring the 3x near 2x, plus 3x, then we say minus 5y, then minus 7y, and lastly plus 3w. So that 2x plus 3x, we get what? 5x. Then negative 5y minus 7y, we get negative 12y. Then plus 3w. So you can see that the expression now consists of unlike terms. So our answer will end there. And this becomes the answer. We can look at another one. Similarly, we also have example 3, which says simplify 2x minus 6y minus 6y minus 4x then plus 5z plus 5z then minus y. So in this case, we also collected the like terms together. You can see that 2x resembles 4x. Bring them together, we shall have 2x minus 4x. Then bring the y's together also. We shall have negative 6y. Then bring the other y also near here, minus y. And lastly, plus 5z. Plus 5z. Now, subtracting this, 2x minus 4x, we find that we get negative 2x. And then negative 6y minus y, we get negative 7y. Negative 7y. Then plus 5z. So you can see that the expression now consists of unlike terms only. So there is no way you can continue to simplify from there. And that becomes the answer. We can now look at another situation, how we can simplify expressions which are in fractional form. Suppose the expression, or suppose the algebraic expression consists of denominators, which we call fractions. How do we simplify them? In this case, we follow the normal process. We simply collect the like terms together. After collecting them, then we bring in the idea of LCM to help us simplify fractions, as we are going to see. For example, simplify an expression like this. Simplify a half a minus a third b plus a quarter a. So we find that in this expression here, there are some terms, some fractions, which have similar variables, that is a half a and a quarter a. Bring them together. So here what we shall do, we shall begin by collecting like terms. This will be a half a, then you bring the quarter near half, but you make sure you bring it together with its sign. So we shall say plus a quarter a, then minus a third B, like that. So after this, we now simplify. To simplify this, we shall look at the LCM. We can get the LCM of everything. Since the denominators are constants, we get the LCM of 2, 4, and 3. And the LCM is 12. So 12 divided by 2, we find that we get 6. And the 6 times 1A, you get 6A plus 12 divided by 4, we get 3. 12 divided by 4, we get 3. And the 3 times 1A, you get 3A minus 12 divided by 3, we get 4. And the 4 times 1B, you get 4B. 4B. So in this case, we shall have like terms there up, which is the 6A and the 3A. So when we add them, 6A plus 3A, we find that we get 9A. Then minus 4B. Everything over 12. So the answer would be 9A minus 4B over 12. So we cannot simplify further from this point, and this becomes the answer. We can look at example 2, which says A plus B over 2, A plus B over 2, then minus 2B minus B, 2A minus B, all over 3. Here, the process is the same. The first thing is to get the LCM of 2 and 3, which LCM is equal to 6. So here we have A plus B over 2 minus 2A minus B all over 3. So that we now get the LCM of 2 and 3, which is 6. 6 divided by 2 is 3. And the 3 times the whole of this, we get 3 into A plus B. We shall open the brackets later. Then we have 6 divided by 3. We get 2. So that 2, we shall multiply it by what? Oh, the whole of this expression, which is 2A minus B. So from this point, we shall now have 3 times A. When we open the brackets, 3 times A, we get 3A plus 3 times B, we get 3B. Then minus 2 times 2A, we get 4A. Now, the negative outside times the negative inside there, we shall get positive. So negative times negative is equal to positive. So the sign here changes to positive. And the 2 times B, you get 2B, all over 6. So from there, we shall now collect the like terms. To collect the like terms here, we find that 3A minus 4B, 3A minus 4A, we get negative A. So we find that we get negative A there. Then also collect the B's. we have 3b plus 2b. You get positive 5b all over 6. And this would be the answer. So the answer will be negative a plus 5b over 6. So another example. Other examples. So in this case, we can have example like this. Simplify 5x squared minus 2x squared. 5x squared minus 2x squared. So for this one here, you can see that the expression consists of some variables. 5x squared, 2x squared. So we subtract. And when we are subtracting, just subtract the coefficients. Then the variable will remain the same. So 5 minus 2, we find that we get 3. Then you put there the variable, x squared. So 5x squared minus 2x squared, we get 3x squared. Roman 2, the other one is 4a squared bc, 4a squared bc minus 2a squared bc minus 2a squared bc. You can see that the expression still consists of same variables. It is only the coefficients which are different, but the variables are the same. That is to say, a squared bc, a squared bc. So we just subtract the what? The coefficients. And here we shall say 4 minus 2. 4 minus 2 gives us 2. Then you put there the variables. The variables remain as they are. That is to say, a squared bc. And this will be the answer. So therefore, 4a squared bc minus 2a squared bc, you get 2a squared bc. Next, we can look at example 3. Example 3, this one says a squared b minus 2b cubed c minus 2b cubed c, then plus 3a squared b plus 3a squared b plus 3a squared b plus b cubed c plus b cubed c. Since it cannot fit, let us rewrite it here. The question says a squared b minus 2b cubed c plus 3a squared b plus 3a squared b plus b cubed c plus b cubed c, b cubed c, then minus 4a squared b, 4a squared b, then minus b cubed c, minus b cubed c. So we want to simplify that. Still, the method is the same. We just collect like terms. Terms which are similar, we bring them together. In this case, we have A squared B. Then we look for another term which is similar to A squared B. You can see that the term similar to that is the 3A squared B. So you bring the 3A squared B near it. There is also this one here, 4A squared B, but this is negative. So we say minus 4A squared B. So we have collected all the similar terms in A squared B. Then we go to another one, that is B cubed C. So we shall say minus 2B cubed C. We look for another term similar to this one also. B cubed C exists here. So we bring this one plus B cubed C as it is. Then another one similar to it is the last one. That is minus B cubed C. Then from there, we collect the like terms. When we collect the like terms, here we shall be adding coefficients. The coefficient of A squared B here is 1A squared B. So I will add this coefficient to this coefficient, then minus this coefficient. In this case, we shall have 1 plus 3, you get 4. And 4 minus 4, you get 0. So it means that the whole of these die. They all cancel because we are having a 1A squared B plus 3A squared B minus 4A squared B. We get 0. So here we get 0. Then we come here, negative 2B cubed C plus B cubed C minus B cubed C. But B cubed C minus B cubed C, you get 0. So these ones also cancel. We are left with negative 2B cubed C. Negative 2B cubed C. And 0 minus 2B cubed C, we get negative 2B cubed C. And this becomes the final answer, negative 2B cubed C. This is basically how we can subtract and add algebraic expressions, which consist of both like and unlike terms. Note, NB, capital letters and small letters are not like terms. What do I mean? That if we have a mixture of capital letters and the small letters, don't treat them as like terms. Like if I have capital A plus small a, these are not like terms. You treat them as unlike terms. By virtue of this being capital letter and this one being small, it differentiates them from being the same. So those are unlike terms. That's why we are saying capital letters and small letters are not like terms. We can go to what we call brackets, the use of brackets. We know that brackets serve the same purpose as they do in arithmetic. When you find a bracket, the sign of a bracket in most cases indicates multiplication. It indicates multiplication. When we are removing brackets in a given expression, you have to multiply. For example, when the term outside is a constant and the term inside the bracket is a variable, you will multiply the variable by the constant. So the process of removing the brackets is by multiplying. So let us look at an example. Example, simplify. We can have simplify 3 into a plus b. 3 into a plus b minus 2 into a minus b into a minus b. So you can see that this expression consists of brackets. The first thing will be to remove the brackets. And the process of removing the brackets is what we call multiplication. So we shall multiply the inside the terms by the outside the terms. So in this case, we shall have, when we multiply this, we shall have 3 times a, we get 3a. And in other words, we shall say 3 times a, then plus 3 times b, then minus 2 times a, 2 times a. Then when you multiply a negative times a negative, we get positive. So plus 2 times b, 2 times b. So that in this case, when you multiply 3 times a, we get 3a plus 3 times b, we get 3b, and the negative 2 times a, we get negative 2a, then plus 2 times b, we get 2b. So, after reaching this step, we can now collect like terms. In this case, 3a is similar to 2a. So 3a minus 2a, we get a. Then 3b plus 2b, you get 5b. And the final answer will be a plus 5b. From this step, we cannot continue to simplify it. We can look at also another example, which is a third a. A third a plus 3 into 5a plus b, 5a plus b, then minus c. So we can say that we have brackets there. So the first thing is to remove the bracket. To remove the bracket, we multiply the outside the term by the inside the terms. So in this case, we shall have a third a plus 3 times 5a, we find that we get 15a plus 3 times b, we get 3b minus 3 times c, you get 3c. So we now collect the like terms. We have a third a plus 15a. So this is a fraction, and then this is a whole number. We are adding a third a to 15a. So writing 15a, remember, is the same as 15 over 1. So it means we shall get the LCM of 3 and 1, which is 3. 3 divided by 3, we get 1. And 1 times 1a, you get a. Plus 3 divided by 1, you get 3. And the 3 times 15a, we get 45a. 45a. Then plus 3b minus 3c. So here we have like terms still. The like terms here are a plus 45a. So a plus 45a, you get 46a over 3 plus 3b minus 3c. So we can see that this expression consists of now unlike terms. Unlike terms. Now, in most cases, an expression which is in this form is not simplified. To simplify it, we have to write it such that all the terms have the same denominator. How can we make the denominators to be the same? To make the denominators the same, here we can create a denominator. The denominator of 3b minus 3c is the same as 1. So we shall get the LCM still of 3 and 1, which is 3. 3 divided by 3 is 1, and 1 times 46a, we get 46a plus 3 divided by 1 is 3, the 3 times 3b, you get 9b, then minus 3 minus that 3 still times 3c, you get 9c. So our final answer will be this one. You can say that it has the same denominator. So that becomes the final answer. We also have another expression which is a bit in a complex form, consisting of different brackets. Still, the process is the same. We can look at another example which has many brackets. Let us see how we remove all these brackets. For example 3, we have 2b plus a, then we have a bracket here. Then we have 3 minus 2. Then we have another bracket there into a minus 5. Then we close the bracket and then another bracket. So you can see that there are so many brackets there. So we shall remove these brackets one by one, until we get the final expression. We shall start with the inside bracket. The inside bracket. To remove it, we multiply the outside term by all the terms inside the bracket. So here, this is how we make it. Solution. We shall have 2b plus the a into this bracket remains. We have 3, then negative 2 minus a, we get negative 2a. The negative 2 times negative 5, we get positive 10. So we have already removed the inside the bracket. We are left with the big bracket outside. We continue to remove. We shall now have 2b plus, we shall multiply a by 3. A times 3, we get 3a minus a times 2a. In this case, we get 2a squared. Then plus a times 10, we get 10a. 10a. So we have got rid of all the brackets. The remaining thing is now collection of like terms. Collection of like terms. And when you look at all the terms, you can say that they are all different. They are not the same, meaning that this is the final answer. We cannot continue from that step. That is basically how we can simplify such expressions. So we are saying that the process of removing the brackets is what is called expansion. Expansion, while the reverse process of inserting the brackets is what we call factorization. I repeat, The process of removing the brackets in a given expression is what we call expansion. And the process of putting in brackets in a given expression is what we call factorization, meaning that expansion is the opposite of factorization. Let us look at a situation where we can factorize expressions. Factorization of expressions. Let us see. First of all, factorization is the process of writing a given expression in terms of its factors. The word factorization comes from factors. It comes from what we call factors. Like 6 can be written in terms of its factors. Factors of 6 are 3 and 2. So another way of writing 6 is 3 times 2. I've factorized. So the process of writing an expression in terms of its factors is what we call factorization. So let us see how we can factorize expressions, how we can write expressions in terms of their factors. The question is factorize. 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 3m plus 3n minus 3 into m plus n. We want to factorize such an expression. So we said that to factorize an expression, we have to write it in terms of its factors. And when we are factorizing, the factorized statement must contain brackets. So here we look at what we call common factors. Common factors. In this case, the 3m plus 3n, when we look at this, you can see that the common factor here is 3. So we shall begin by pulling out the 3. How do I pull out the 3? Here we shall say, we say 3 into. We create a bracket there. Now, which term can I multiply by 3 to give us a 3m? You can say that the term is m plus. Which term can I multiply 3 with to give us a 3n? You can say that it is n. Such that when I open the brackets, I go back to the original statement. Because 3 times m, you get 3m. And 3 times n, you get 3n. By so doing, I've factorized such an expression. We come to this one here. For 3 into m plus n, this one is already factorized because it consists of a bracket. So we shall just write 3 into m plus n. Having done that, we still have a common factor. The common factors are m plus n and m plus n, meaning that these common factors have to be pulled out. But when pulled out, it will be meaningless. So we have to leave it in this form. If this term 3 was different, I would subtract 3. This one's outside the bracket. I would say 3 minus 3, and then 1 of this outside. But since this term is the same, it will remain as it is. So we have 3 into m plus n minus 3 into m plus n. This becomes our final answer. We have factorized. Then we also have another example. Example 2. We can have AR squared, AR squared plus AR to power 4 plus AR to power 4, and then plus AR to power 5 plus AR to power 5. We want to factorize this also. To factorize this, you look at common factors. You can see that the common factors here are AR, because we have A in every term. Then for the R, we have R. But when we are factorizing, we consider the least value, or the least term in a given expression. In this case, for the case of R, the least term there is the R squared. So it means our common factor will be AR squared. AR squared, we pull it out. Now, what can we multiply AR squared with here to give us AR squared? You can say that it is 1. Or we simply say AR squared divided by AR squared, you get 1 plus. What can we multiply AR squared with here to give us AR to power 4? The A is already existing. We are left with R to power 2, such that AR squared times R squared, you get AR to power 4. Plus, the A is already there. What can we multiply R to power R with, R squared with, to give us R to power 5? You can see that it will be R to power 3. So this becomes the factorized statement. You can see that when you open brackets, you go back to the original statement. AR squared times 1, you get AR squared, plus AR squared times R squared, you get AR to power 4, plus AR squared times R to cubed, you get AR to power 5. So here, this becomes the factorized statement. Let us now look at what we call factorization by grouping. Factorization by grouping. When the terms of an expression which do not have a common factor are taken pairwise, a common factor can be found. This method is known as factorization by grouping. Let us see how we can factorize by grouping. We shall look at an example on how to factorize expressions by grouping. The question says, factorize 3AB plus 2B, then plus 3CA, then plus 2C, So we are going to factorize this by grouping. Now, to factorize by grouping, we consider those terms which have variables which are similar, which have variables that are similar. So in this case, when we look at these terms here, when we look at 3AB plus 2B, then 3CA plus 2C, we can see that between 3AB and 2A, you can see that B is similar. Between this one, you can see that C is what? Is similar. So what we shall do, first of all, we are having 3AB plus 2B plus 3CA plus 2C. We are going to factorize this group and then we factorize this group separately. To factorize this group, in this group, we find that B is common. So I will pull out B. When I pull out B, I will be left with the 3A plus B is already out, we are left with the 2. Plus, we come here. In this group, you can see that C is common. Since C is common, I will pull it out. We are now left with the 3A plus, and then 2, since C is already out. Now, you can see that in our expression, inside the bracket, the expressions are the same. 3A plus 2, 3A plus 2. So since it's common, it means we continue to factorize further. We continue to factorize further. So to factorize further, we shall now have the 3A plus 2. This is common because we have 3A plus 2, we have 3A plus 2. So we pull it out into, in this group here, we are now left with the B plus. The 3A plus 2 is already out, we are left with the C. And this becomes the final answer. So basically, this is how we factorize by grouping. And this becomes the final answer. We can look at part B of the expression, which also requires us to factorize by grouping. The question says AB plus BX plus BX minus A minus X. So as I said, this one is a bit technical. Pull out those terms which have, collect those terms which have similar variables together. You can see that we have a term in a X, then A, and then A. We bring them together. So in this case, what we shall do, we shall say AB is related to what? To A, because there is A there, there is A. So we say minus A. Then we say plus BX, because it has the element of X in it, bring the X's together, we collect them together. Also minus what? Minus X. So that we have this group, and then we have this group. Then we factorize them separately. In this group, A is common, so I will pull out A. Into, we are left with B, minus 1. Because A times 1, you get A, plus. In this group, you find that X is common. Pull out X. We are left with B, minus. What can I multiply X with to give us X? We find that it is 1. So we can see that the expressions inside the bracket are now the same. Since they are the same, continue to factorize. We shall have B minus A, minus 1. Since they are common, pull it out. Here we are left with the A, plus. Here we are left with the X. And then we close. This becomes the final answer. This is basically how we can factorize expressions by grouping. Algebraic fractions. We look at algebraic fractions. In algebra, fractions can be added and subtracted by finding what we call LCM of the denominators. The LCM stands for what we call the lowest common multiple. So if we have the denominators in a given fraction, and when we are adding them, we have to get their lowest common multiple. So in this case, how do we simplify fractions? To simplify fractions, we aim at writing those fractions as a single fraction. As a single fraction. A single fraction is that fraction which has the same denominator throughout. A combination of fractions having the same denominator is what we call a single fraction. So let us see how we can look at an example. Express each of the following as a single fraction. As a single fraction. We can have x minus 1 over 2 plus x plus 2 all over 4 plus x over 5. We want to write this as a single fraction. To write it as a single fraction, we mean that they must have the same denominator. The denominator must be the same. For it to have the same denominator, it means we have to find the LCM of 2, 4, and 5. The LCM of 2, 4, and 5 in this case is 20. So our solution will be x minus 1 over 2 plus x plus 2 over 4 plus x over 5, whereby the LCM is what? Is 20. So 20 divided by 2, we get what? 10. And the 10 times the whole of this, we get 10 into x minus 1 plus 20 divided by 4, you get 5. 5 times the whole of this expression, we get 5 into x plus 2. Then plus 20 divided by 5, we get 4. And 4 times x, you get 4x. Then you open brackets. To open brackets, we shall have 10 times x, you get 10x, minus 10 times 1, you get 10. Then plus 5 times x, you get 5x. Then plus 5 times 2, you get 10. Then plus 4x, all over 20. So in this case, we have some like terms. The like terms there are, we have 10x plus 5x. 10x plus 5x, you get 15x. Then plus 4x, you get 19x. So here we get 19x. Then we come to this one, to the constants. Negative 10 plus 10, you get 0. So you find that this one is a cancel. So we are having 19x out of 20, and this becomes the final answer. So we have already simplified such a fraction. We can look at another example 2. Example 2 says a plus b over b. A plus b over b minus b minus a over a. We have to write this as a single fraction. The process is the same. We just find the LCM of b and a. The LCM of b and a is ba. ba divided by b, the b's will cancel. We are left with the a. And the a times the whole of this, we get a into a plus b minus ba divided by a, the a is cancelled. We are left with the b. And b times the whole of this, we get b into b minus a. Then we open the brackets. This now gives us a times a, we get a squared, plus a times b, we get ab, then minus b times b, you get b squared, then negative times negative, you get positive, and then b times a, you get ba, all all over AB. Do we have like terms? Like terms, you can see that yes, we have AB is the same as BA under commutativity property. Using the property of commutativity, you find that AB is the same as BA. So the answer will now be A squared plus 2BA minus B squared all over. So in this case, I can write off this. So our answer will now be A squared plus AB plus BA, you get 2BA or 2AB, all the same. Then minus B squared, everything over AB, and this becomes the answer. I have written it as a single fraction because they now share the same denominator. That is how we write it as a single fraction. We can look at another fraction, that is Roman 3. Another example. It is saying simplify 1 over 3 into A plus B plus 3 over 8 into A plus B plus 5 all over 12A, like that. So in this case, the method is just the same. What we shall do, we shall still get the LCM of all these terms. You find that the LCM, we shall find the LCM of 3, 8, and 12. Then we also find the LCM of A plus B, and then A. So you can see that the LCM here of 3, 8, and 12 is 24. 24. Then 24A into, then these ones are common, which is A plus B. So this will be the general LCM of everything. 24A into A plus B. So we are going to divide now. 24A into A plus B divided by 3 into A plus B. First of all, 24 divided by 3, you get 8. And then this AB, the A plus B divided by A plus B, you get 1. And then it means we are left with the A. So the answer will be 80A only. This one divided by this is 8. This one divided by this is 1. And the A divided by that, we are left with only A. Because this one is a cancel, this cancels with this one goes 8, and we are left with the A. So that A times 1, you get A plus. This one divided by this. The 24 divided by 8, you get what? We get 3. And that is 3 times 3 times 3, you get 9. Into the A plus B will cancel with the A plus B, and we are left with the A only. So which is 9A. So plus the whole of this divided by this. 24 divided by 12, you get 2. And the 2 times 5, you get 10. You get 10. But we still have some terms. A divided by A, you get 1. And the A plus B divided by that, it remains as it is. So we are left here with only A plus B only. Here, to make matters easy, you can even compute it from side work by saying 24A into A plus B all over divided by 12A. You can say that this A cancels with this A. By 12, once by 12 goes 2 times. And that 2 times 5, you get 10 into this one, into A plus B. That is how it comes about. So here we now open the brackets. We have 8A plus 9 times A, you get 9A plus 10 times A, you get 10A plus 10 times B, you get 10B all over 24A times A, you can leave it in that form, 24A into A plus B. Up there, we have like terms. 8A plus 9A, you get 17A. And 17A plus 10A, you get 27A. Then plus 10B all over 24A into A plus B. So this one becomes our final answer. We cannot continue from there. This is how we simplify fractions. We are looking at now simplification by factorization. How we can simplify numbers by factorization. How do we simplify numbers by factorization? To simplify numbers by factorization, what we do is, if we are given a numerator and then denominator, factorize the numerators separately and then factorize the denominators separately. Then where there are common factors, they will cancel, and then you are left with an expression, as we are going to see. An example. Simplify. Example. The question says simplify. Is 18xy, 18xy minus 18xr minus 18xr over 9xr over 9xr minus 9xy. So in this case, you will find that 18 is common, pull out 18. X is also common, pull it out. Inside, we are left with the y, minus, minus r. All over, down here, you can see that 9 is common. X is also common, pull it out. Inside there, we are left with r, minus y. So from there, the x will cancel with the x. 9 by 9, 1, 18 by 9, you get 2. So our answer will now be 2 into y minus r over r minus y. So this becomes the final answer. The y minus r is not the same as a r minus y, so they don't cancel. You leave it as it is. Should you cancel it, it means your answer will be wrong. That is about factorization. For that reason, therefore, you must be able to factorize expressions. We can look at now the last part of algebra, which we call substitution. Substitution is the process of giving the variables specific values in any expression. In other words, substitution is replacement of something by another. When you replace something by another, it means we have substituted. How do we substitute numbers for letters? We can look at examples. Example, there is a question which says, evaluate the expression x squared plus y squared all over y plus 2, if x is equal to 2, if x is equal to 2 and y is equal to 1. So they want us to express this expression. If x is equal to 2 and y is equal to 1. Here we substitute. Where there is x, we put 2. Where there is y, we put 1. So when we do that, it means we have carried out the process of what we call substitution. So let us substitute. So to substitute, here we shall have x squared plus y squared all over y plus 2. This one is the same as where there is x, I will put 2. But since the x is squared, I will square the 2. Plus, where there is y, I put 1. Since the y is squared, I square the 1. Over y is 1 plus 2. So that we now get 2 squared is 4, and 4 plus 1, you get 5, all over 1 plus 2, you get 3. And therefore, 5 divided by 3, you get 1 whole number and 2 over 3. So this becomes the final answer. 1 whole number and 2 over 3. That is how we substitute. So generally, substitution is replacement of something by another. When we are substituting numbers, in mathematics, to substitute is we normally replace variables by known values, which are numbers. So that one has marked the end of our lesson today. For that reason, therefore, you can be able to attempt any question on algebra. Thank you for listening.